Hello everyone. Welcome back to the world of embedded system. In the last video, we saw how a C program gets converted into a machine code and is finally flashed inside a chip. But today, I want to ask you a simple question. After flashing the code, where does it actually run? And where does it store all the information? That's exactly what we are going to learn today. You will be understanding what a microcontroller is, what's inside a microcontroller, how the CPU finds codes, variables, and peripherals using a memory map. All these concepts we'll be learning today. Okay. By the end of this session, whenever you look at a microcontroller, you won't just see it as an black box. Okay. So let's get started. Let's forget about definitions for a minute. Whenever we start learning something new, we often jump straight to definitions. But in engineering, understanding why something exists is more important than memorizing what it does. So, before we talk about microcontrollers, let's think about the world around us. Take a look around your room. You might see a television, ceiling fan, a hair conditioner, and a mobile charger, your smartwatches, or even maybe your microwave oven in your kitchen. Now, here's something interesting. All of these devices are electronic devices, right? But simply being an electronic device doesn't make them smart. For example, if I connect a bulb directly to a battery, it will glow. There is no intelligence involved in it. It's just electricity doing its job, right? But what happens when a washing machine decides how much water to use? And one more example, we can take it as our air conditioner. It can measure the room temperature and automatically turns the compressor on and off. Or also, even our smartwatches counts our step and displays the heartbeat rate. Correct. So these decisions require something more intelligent, right? And that intelligent come from microcontrollers. A microcontroller is essentially the brain of an embedded system. It receives information from the outside world, it processes the information, and based on the information, the we will be writing the program for it. Okay, it makes decisions and controls the output also. Let's consider a simple example. Imagine you're designing an automatic street light system. During daytime, the system light should remain off. At night, the street light should automatically turn on. How would you make that happen? First, we need a sensor that can measure light intensity. That sensor continuously sends information. Now, something has to read that information, something has to compare it with the threshold values, something has to decide whether it's a day or night, and finally, something has to switch the lamp on or off. And that something is the microcontroller. Without the microcontroller, the sensor alone is useless. Without the sensor, the microcontroller has no information. Together, they form an embedded system. This is why we often say sensors provide inputs, microcontrollers make decisions, actuators produce outputs. Now, let's compare the microcontroller with a computer. At first glance, both seems very similar, but execution wise, both like through execution wise also they are similar, and you can say both has a memory, both has processors, and also you can say both can perform calculations. So what is the difference between computer and a microcontroller? The difference lies in their purpose. A computer is designed to perform many tasks, different tasks. You can say it like we can browse the internet, watch videos, edit documents, and also we can attend meetings. We can play video games in our computers, right? But a microcontroller is designed for a specific task. A washing machine microcontroller does not need to browse the internet. A microwave controller does not need to play videos. And also, our TV remote does not need to run Microsoft Word. Each device perform a limited set of functions, right? Because of this, microcontrollers are small, cheaper, and consume far less power than the computers. This is why you will find the microcontroller mostly everywhere. Okay, so in our modern vehicles, we see dozens of microcontrollers. In a smart home, we see dozens of microcontrollers. Even in the medical equipments, we see microcontrollers. The industrial automation systems also they contain microcontrollers. Even the keyboards you're typing probably has a microcontroller in it. So once you start noticing them, you will realize that microcontrollers are hidden inside almost every modern electronic product. And that is exactly why embedded system is such an important field. Whenever someone asks you what is microcontroller, don't think of a technical definition. Just think about the role it plays. A microcontroller is a small computer designed to monitor inputs, process information, and control output for a specific application. So, this is the definition for a microcontroller. For today's PPT, please go and check our Telegram link. The link will be given in the description box. Okay, so you will be getting the PPT of today's session and the previous sessions also inside that Telegram link, and also you will be getting the updates of the next videos. Now, let's open this microcontroller and see what's inside it. Of course, we can't open it physically, but logically, we can open that microcontroller. So, inside every microcontroller, you will usually find four important blocks. Okay, the first one is CPU block, second one is RAM, the next is flash memory, and the last one is EEPROM. In certain controllers we have this, and in some controllers we don't have this EEPROM. Okay, think of it like an small office. Each department has its own responsibilities. Let's understand them one by one. Firstly comes the CPU. CPU stands for Central Processing Unit. This is the brain of the microcontroller. Whenever you write a code like turn on the LED, the CPU is the part that actually executes that instructions. The CPU never gets tired of running the code again and again. It continuously runs that code by these three process. Okay, the process is like firstly it will fetch. What it will fetch, what is firstly what fetch means? Fetch means reading the instructions. So what the CPU will do, firstly it will read the information or it will read the instructions. Secondly, what happens is it decodes. Decode means understanding the instructions. Firstly, it will read, it will understand, and then it executes. Execute means performing the instructions. So, firstly, it reads the information or the instructions, it understands it, and then executes it. This cycle happens millions of times every second. So, if somebody asks, who is actually running my code? The answer will be the CPU. Next is RAM. Think of RAM as an working table. Suppose you're studying for an exam. All your books are inside a cupboard. Okay. But while studying, you don't keep opening the cupboard every second, right? You take the books and place them on your table. Similarly, RAM works exactly like this. Okay, whenever a program is running, it it creates the variables, or it reads the variable, it reads the buffer, and temporarily it is stored inside the RAM. Okay, the CPU accesses RAM very frequently because it is fastly accessible. But there is something more important. RAM forgets everything when power is turned off or power is removed. If power goes off, the RAM becomes empty. That's why it is called as an temporary memory. Okay, now let's talk about the flash memory. Remember the cupboard example. Flash memory is like that cupboard. This is where your program is stored permanently. When you generate an hex file and flash it into the microcontroller, it stores in flash memory, and even if power is removed, the code remains there only. Tomorrow, when you come and power it back, the CPU can still find the code getting executed in the sense, the code which you have uploaded or flashed yesterday, so that can be executed even today after powering it up. Okay, so in simple words, RAM is temporary storage, flash is permanent storage. Okay, so for today's PPT and for free resources, please join our Telegram group. The link will be given in the description box. Now let's come to double EPROM. Many beginners get confused between flash and double EPROM. The easiest way to understand or to remember it is, flash stores the program, double EPROM stores the important data. For example, imagine you're building a digital clock. Okay, the password should remain saved even after power is removed or power is turned off. Okay, where you will store the where you will store the power where you will store the password. So the best option is double EPROM. Or suppose you have calibration value of a sensor. Those values must remain even after resetting. So at that time, you can use this double EPROM. Double EPROM is used for this purpose only. So it will store the data permanently so that we can recover it even after we turn the power off and on. Okay. So now let's see the complete picture. First, your program is stored in a flash, and when power is applied, the CPU starts reading the instructions from flash. While executing, the CPU uses RAM to store the information temporarily. If permanent settings are required, they are stored in double EPROM. And that's how a microcontroller operates internally. CPU works with memory to execute your program. Now, here is an important question. How does the CPU knows where the flash is? How does it know where RAM is? And also, how does it know where the GPIO registers are? I mean the input and output pins are. Imagine Bangalore is an city. Okay. Every house has an address. Without address, nobody can find anything. Similarly, inside microcontrollers, every resource has an address. RAM has an address, flash has an address, uh, a GPIO registers has their own address, timer has its own address, and also the arrangements of all these addresses is called as memory map. Think of the memory map as an Google map for this CPU. Okay, suppose flash starts here, RAM starts here, GPIO pin starts here, and the CPU does not reach randomly. It directly goes to the required address. Okay, if it wants an instruction, it goes to flash. If it wants an variable, it goes to RAM. If it wants it wants to control some LED, it will go to the GPIO pin. So everything will be given here only. Okay, so it just whatever work it has to be done, it just go check the address, go to the particular place, fetch the information or give the information. Everything is address based inside the memory mapping. Okay, so today we have understood three important concepts. Firstly, what is a microcontroller? Second, what's inside microcontroller? And third, CPU finds everything using a memory map. Okay, so we have covered the uh, fundamentals of the embedded system course. So, in our next video, we'll be going to learn even more deeper and understand the registers and how the software directly controls the hardware. So we'll be learning it in the next session.